Hey guys, and welcome back to another video in this week's Basic Algorithms in Java tutorial. Like I told you guys last video, we are focusing on greedy algorithms for this week. And last video, I told you guys a story about an example of when we would use greedy algorithms with our coin change. I explained to you what the greedy algorithm was. We talked about when not to use our greedy algorithm and why sometimes greedy algorithms don't give us the best solution in the long run. And I showed you guys a classic example of coin change problems. So we've got our greedy algorithm concept down. The next part that I want to talk about is I want us to code it up. So we're going to be basically doing everything that I explained for this picture in the last video, but we're going to be writing it in code. And so last video, I left you guys on a little cliffhanger. I asked you guys what loop we should use that should keep on repeating until the statement is no longer true. And so we're going to first start off with some basics, and then in the next slide, we're going to see if you remember that loop. So a couple of things. The first thing that we want to do is just some setup because we want to ask for some user input, right? It's been a while since we've taken user input. So we're going to ask for some user input and take in the value there. So whatever the change value is. And then since we're going to count how many like quarters, nickels, and dimes and pennies we need to use, well, then we have to set a variable for that, right? We set a count. We started off with 0, and every time we say subtract 25 cents or we figured out that we need another quarter, we will add 1 to one of these values here. So let's go ahead and do that. So let's go to Replit, and I'm going to create a new Java file, create, and we're going to just take in user input. It's actually been quite a long time since we've last done that. So this should be a good reminder of how to do that. We say scanner is equal to new scanner system.in. And remember, guys, this is similar to some classes and objects that we've seen before, right? But remember, lowercase scanner is going to be the name of our scanner that we're going to use. Import java.util.star because, you know, scanner is one of those things that must be imported. Now, we have our scanner ready, so let's go ahead and ask a question. So system.out.println and be like, please enter the amount of change you would like to calculate. There we go. And so once we've asked this question, whatever number immediately comes next is going to be the value that we save as our change, right? And usually change, again, isn't going to be a whole number, it's going to be a decimal. So we're going to say double change is equal to scanner.next double, or whatever double that comes next. And then we're going to put a semicolon. So just to really quickly verify that we took our input correctly, I'm going to run this piece really quickly and make sure that our change gets printed out correctly. So let's run it really fast and give it a second to run. So one thing that I want to mention while we're waiting for Replit to load is that we are going to start off with small change values. So in this example, we're going to be using change values like quarters, nickels, dimes, and pennies, meaning that our change values should be small, right? So that way we can make everything like 25, 10, 5, and 1 instead of 0.25, 0.1, 0.05, and 0.001, right? So however, this isn't always the case because in the future, when we get into bigger ones like $1 bills, $10 bills, $100 bills, then we need to start doing things differently. And we'll talk about that in a second. But let's verify that everything works. 0.52, 0.52. Our input has been taken in correctly. So let me add a comment here, input. Then we're going to initialize coin values. So int quarters is equal to 0. Int dimes is equal to 0. Everything starts from 0 since we don't know yet, right? We don't know how many we're going to have. And int pennies is equal to 0. Now, if you aren't from the US and you're watching this, then you might be a little confused. But basically, you are putting your currency here. Whatever currency you have, whether it's, I don't know, euros or I don't even know, honestly, but you would put that name here and then later remember those values. So in America, we have quarters, dimes, nickels, and pennies. Quarters are 25, dimes are 10, nickels are 5, pennies are 1. So we've initialized our coin values. Last but not least, we're going to make our change into a whole number, meaning that since we want to work with quarters as 25 and not 0.25, we have to change 0.52 into 52. So how do we do that? We do change star equals 100, which basically means change is equal to change times 100, because when we multiply it by 100, we can use big numbers now. So all of our setup is done. Good job, guys. Now back to our topic of the loops. And so the answer is we're going to be using while loops. Why while loops? Because we want it to keep on subtracting the largest value until we no longer have that amount in our change. And then we move on to the next largest value. We keep on subtracting the next largest value until that one no longer works. So while loops are the perfect answer for that. So basically, we're going to use while loops for all our different currencies. So we'll do first for quarters, because those are the biggest, then dimes, nickels, pennies. Basically use while loops. They're the same while loop, same idea, but just go biggest currency, next biggest, third biggest, etc. And in our while loop, we're going to subtract the change amount. We're going to subtract the amount. So quarters are 25. We're going to subtract that from our change because our change needs to change. Our change needs to get different each time we run our loop. Otherwise, it'll just keep on running forever. And then we're going to add 1 to the count of whatever currency value you're using here, right? 25 is a quarter. So every time we subtract 25, we add 1 to the number of quarters we need. So yeah, let's go ahead and do that. So use our while loops. This part is honestly our greedy algorithm part, in my opinion. So we're going to say while, that I spelled while wrong. While, and let me zoom in a little bit here. While change is greater than or equal to 25. It can be equal to, because we could just have an even amount of quarters. We're going to change minus equals 25. Which basically means change is equal to change minus 25, and we're going to add 1 to the number of quarters we need, right? So we do the same thing for dimes. When there's no longer 25 cents, as long as it's greater than or equal to 10, sorry, I just blanked on how much a dime was worth. Then we're going to do change minus equals 10, and then dimes plus plus. Now here's something that I want you guys to think about. There's no space here. What is the maximum numbers of dimes we could possibly have? And there's really only one answer, and the answer is 2, right? Because as soon as we have 3 dimes, that would mean 30 cents, and you could put in a quarter for that, right? So we will never have more than 2 dimes, and you guys can put this in the test if you want, but we'll never have more than 2 dimes. So we're going to do the same thing for nickels and pennies, and I'm not going to waste your time. I'm going to copy paste. So while change, but make sure you do this as 5. Minus equals 5, and then we are doing nickels plus plus. Change this to 1, and then pennies plus plus. There we go. Wonderful. So this is our while loop. We've made sure that it's going to keep on running over and over until there's no more change left. So the last thing we have to do is print out the coin count. How many do we need of each coin? So system.out.println quarters plus quarters. And I'm going to repeat this for nickels, dimes, and pennies. So dimes, nickels. Guys, I feel like I need to go back to kindergarten and learn how to count again. Pennies and pennies. So let's go ahead and try it, shall we? Let's see if it works or not. It might not. Let's run our code really quickly. And the first, remember, since everything's working in like whole numbers, and since our coin values like are small, we're going to give some smaller values first. So let's say like 1.72. That is going to give us 6 quarters, 2 dimes, 0 nickels, and 2 pennies. What does that mean? 6 quarters, 4 quarters is $1, 2 more is $1.50. So it's $1.50 plus 20 cents, $1.70 plus 2 more pennies is going to be $1.72, right? So perfect. How fast was that? Super fast, right? And so we can run it one more time just to show you. For example, 0.99 is going to be 3 quarters for 75 cents, 2 dimes for 95 cents, and then 4 pennies, right? So far, we haven't really used our nickels very much, but then I'm going to propose to you a new solution. So we already know that this works, right? Our greedy algorithm solution works very well. But what happens when I start getting change in big numbers? So like, remember my example in the last video about the cookie business? My cookies were only worth, he only bought like $300 worth of cookies, but he paid in like a $500 bill. So I had like $187 and like, I don't know, 64 cents to return to him. Whoops, that is not okay. Hold on, I should probably restart this code. So we are gonna say that this time I need to give him $167.42. That's gonna give me 669 quarters, 1 dime, 1 nickel, and 2 pennies, which is good, right? It shows us that, hey, this is very fast. But do you really think people will be happy if I hand them 669 quarters, 1 dime, 1 nickel, and 2 pennies? No, because I for sure would not be happy. I'd be like, hello, give me some bigger bills, right? So this is where the second part comes in. So right now, the code that we have is good for small transactions. But if we wanted to give this to restaurants or bigger companies or grocery stores to use, it might need to be upped a little more, right? So how might we do that? We could do that by creating more coin values. So int dollars is equal to 0. And instead, I guess since we could do like $10 bills, $100 bills, but we're going to stick to $10 bills, but the same idea applies for bigger things, right? So I could do this for $100 bills, $1,000 bills. Do they even have those? I don't know. But I'm just going to do these two for now just to show you. At this point, we no longer need to multiply it by 100. Why? Because we don't need to change things into a whole number anymore, because 167, when we want to use, for example, $10 would be 10. And then a dime would be 0.10. So we're going to work with decimals. So no longer need to make change into a whole number. Get rid of that part. Our while loops. We need 2 more while loops for our $1 and for our $10. But these while loops are going to look slightly different. So change is going to be 10 minus equal 10 and then $10 plus plus. So if $10 is 10 and then dollar is going to be 1. So change minus equal 1 and then dollar, is it dollar or dollars? Plural, okay. Dollars plus plus, then quarters can no longer be 0, can no longer be 25. It would be 0.25, 0.25. This one would be 0.10, 0.10, 0.05, 0.05, 0.01, and 0.01. Does everybody see that? When I made things bigger, then the smaller coin values had to be turned into decimals. So I'm going to do this, but for my $10 bills. So $10 plus $10. Instead of, we are going to do $1 and then change it to dollars. Now let's go ahead and try it, right? So I'm not going to give it anything in the hundreds, because I don't want us to have to give like $20 bills or like 20 $10 bills. But you know how to do hundreds. You would just add another one up here that was like $100 bill and then set it equal to 100, right? So let's say our change is going to be $80 and 25, or no, let's do 27 cents or 28 cents. There we go. So we would need 8 $10 bills, no $0 bills, 1 quarter, and 3 pennies, right? And this is correct. If you add it up, it's correct. So this is something that a restaurant or a grocery store could all use, because imagine if cashiers had these things, right? Instead of having to do the math themselves, they could enter it in. So we could say the change needed for us to do stuff, maybe we do like 117.23. That is going to need 11 $10 bills, 7 $1 bills, 2 dimes, and 3 pennies, right? So this is something greedy algorithm wise that many different real life situations could use. And we've coded it all out together. It made sense. It was relatively simple. So everybody sees how good this is, right? And how much it applies to real life situations and how much it can actually help us right now in our world. So that is something that I really like about this lesson. And I hope you guys enjoyed it as well. I will see you guys next week for another new algorithm for us to learn about. So I'll see you guys then. Bye, guys.